Hello students, today we are going to discuss about the atomic structure, the lecture number 1, and which is the first chapter of the subject, that is chemistry. So let's start the class. So students, today we will discuss about the atomic structure. As you know, this is the first chapter of the chemistry. Of your chemistry paper. The module number is 1 and lecture number is 1. Okay, so this is the our subject, that is chemistry. The subject code is CH101 and or CH201. The credit number is 3 and contact hour is 35. Okay, so these are our course outcome. This is the lecture plan of the atomic structure. This is lecture number 1, lecture number 2, lecture number 3 and lecture number 4. So next 4 days, next 4 classes, we will discuss about the atomic structure. Okay, let's have a look at the objectives of our today's class. So today we discuss about the atom, electron and neutron. Generally we will discuss about the atomic structure. Next we will discuss the Rutherford atomic model. Generally we discuss about his experiment and what are the merits and demerits of Rutherford atomic model. That also we will discuss. Yes, merits and demerits. Next, after Rutherford atomic model, to sort out the all type of demerits of the Rutherford atomic model, next we have Bohr's atomic model. Okay, so also we will see the Bohr's atomic model. In this Bohr's atomic model also we will derive the atomic radius and the radius of the atoms, and also the energy of the electrons. Okay, also we will derive, and some of the numericals also we will solve, which is based on that atomic radius and atomic energy. So these are all the today's objectives of the class. Okay, next, what is atom and what is the constituents of atoms? Yes, already you have read it. This is the basics of the chemistry. Okay, any compounds, any elements, generally first of all we should have the idea of the atom, right? So atoms are generally, there are two parts. One is nucleus, one is electrons. Okay, in nucleus generally, we know, in the atom, at the center of the at the center of the atom we have the nucleus is generally, the constituents of the nucleus is generally neutron and proton. Okay, the mass of the proton is 1 mu and charge generally we consider that is +1. For neutron, the charge is 0 and mass is 1 mu. Okay. For electrons another part of the atom. So we consider that electrons are moving around the nucleus. Okay. We are having around the nucleus, we are having the the electrons, probability of finding electrons. Okay, so that we will discuss by Rutherford atomic model, by Bohr atomic model. Then after all we will discuss about the Sommerfeld atomic model. These are the some of the atomic model by which you can get the idea actually what are the components, constituents of the atom, and what is the arrangement of this nucleus and electrons. Okay, and what will be the energies. So the electronic cloud determines the size, volume of the atom, but does not significantly contribute to the mass. The mass of the electron is 0.0005 mu, very small particles, and charge generally we consider as the -1. Okay. Generally, the electrons determine the atomic number, and we are indicating this atomic number of any element, that is by Z. Okay, so this is the atomic structure. After the modified theory, we can know these are the atomic structure of these are the arrangement of the electrons, neutrons and protons. Generally what will happen in the nucleus, we have the protons and neutrons, and around, and this is called nucleus. Okay, and around this nucleus, what the electrons will be revolving, will be moving. Okay, moving around this nucleus. So this is overall atomic structure of our of any elements that we have in the periodic table. Okay, now Rutherford experiment. So what is Rutherford experiment? Actually, from the Rutherford experiment, we can know what are the arrangement of the nucleus, what are the arrangement of the electrons. All these things, for all these things, we have an idea. We can get an idea about the any atomic structure. Okay, so what he has done, this is a source of alpha particle. Okay, in his experiment, he what he has used polonium. Okay, so as a generator of the alpha particles. Generally we know alpha particles, the symbol of the alpha particle is He plus 2. Okay, alpha particles, that is He plus 2. So this source is the generation of the alpha particle. Now this is a gold foil. Okay, this yellow color thin foil, that is called, that is the material the material of that foil, thin foil, is, that is gold foil. So in this thin foil is bombarded by the alpha particle. Okay, and this fluorescent screen, that is the actually he has used this fluorescent screen so that he can understand if the alpha particle will will hit the gold foil, what will be the deflection of this alpha particle, how they are acting with this gold foil. For that he has used this fluorescent screen. Okay. Okay, so what will happen while the alpha particle will hit this gold foil? What will happen? The maximum alpha particle, you can see the maximum alpha particle is passed straight through the gold foil. This is a gold foil and this is the alpha particle, and it can pass through the pass straight through the gold foil. Okay, this is the first observation. This was the first observation of his experiment. The second observation is very few alpha particle will be deflected. Okay, and very one or two alpha particle will reflect back 180-degree, right? So these are the some of the observations that we can get from the Rutherford experiment. And from his experiment, there are some of the consequence or conclusions that we can guess, or we can indicate that if the almost all the alpha particle will be what will be go straight through the gold foil, that means the maximum space of the atom will be vacant. So that's why the no deflection of the alpha particle can pass through the gold foil straight. Okay. Second one is the whatever alpha particle is reflected back 180 degree. Whatever that means, at the center of this the gold foil, there will be some heavy positive charge. For that, the alpha particle will be deflected back. Okay, so it will hit the positive charge, the heavy mass positive charge, and it will deflect it back. Okay, 180 degree. So that means that heavy positive charge, that heavy mass with the positive charge, that is called by the nucleus. Understand? So maximum space of the atom is vacant, and at the center of the atom we have some all the masses are masses we have for the atom, that is at the center. Okay, and the center, the nucleus, that is called by nucleus, and nucleus is positively charged, because that is why the alpha particle is also positively charged. That is why this alpha particle will be repulsion, due to the repulsive force it will reflect it back 180 degree. Understand? So this is the second conclusion. And third one, very few, you can see very few alpha particle will be deflected, so deflected or distorted from their path. So that means what? That means electrons, that means the around the nucleus the electrons are moving, and electrons are negatively charged, and helium is positively charged. That is why one interaction will be there, and that is why they are reflected, okay, or deflected from their straight path. So these are the some of the conclusions that we can make from the Rutherford model. That means, I'm again repeating, so according to the Rutherford experiment, we can conclude that most of the spaces of the atoms are vacant. Second is, at the center of the atom we have positive charge, and all the masses are at the center of the atom. So that is called by nucleus, and electrons are revolving around the nucleus. Understand? So these are the some of the conclusions, some of the statements that we can get from the Rutherford experiment. That means a major fraction of alpha particles bombarded towards the gold sheet pass through it without any deflection. That is why all the maximum spaces of the atom is empty. Some of the alpha particles were deflected by the gold sheet by very small angles, and hence the positive charge in an atom is not uniformly distributed. The positive charge in an atom is concentrated in a very small volume, okay, and very few of the alpha particles were deflected back 180 degree. That is, only a very few alpha particles had nearly 180 degree angle of deflection. So the volume occupied by the positively charged particles in an atom at the center. Okay, so these are the some of the statements that we can get from the Rutherford experiment about the atoms. Okay, so what are the limitations of Rutherford experiment? Okay, there are some of the limitations that we have. Like, according to the Maxwell, what will happen if one charged particle will be accelerated? Okay, will be accelerated. This particle will emit continuously some of the uh, electromagnetic radiations, like these electrons. Okay, this is one electron. This electron is revolving around the nucleus. This electron is charged, and nucleus is also positively charged. So according to the Maxwell, what will happen while the electron will be revolving around the nucleus? It will continuously emit some of the energy. electromagnetic radiation. Okay, and hence the electron, what will happen after some time, the electron will loses energy, and once it will just collapse into the nucleus. Okay, so hence an electron revolving around the nucleus should emit electromagnetic radiation. Ultimately, the electrons would collapse into the nucleus. So all the electrons, what will happen? All the electrons will collapse into the nucleus. Whatever electrons revolving around the nucleus. Okay. So this is, if we follow the Rutherford model, this case will take place. That means Rutherford model cannot explain the stability of an atom, because this is not the practical case. Generally, the atoms are very much stable. So the electrons are not collapsing into the nucleus. So this is not the actual case, and this case is not explained by the Rutherford experiment. Okay, and one more thing, he did not say anything about the arrangement of electrons in an atom, which made his theory incomplete. And third thing is, he could not explain the line spectra of hydrogen atom. We are getting some of that we will discuss in our next. We will discuss in the class, that what is line spectra of hydrogen atom. Okay, so that line spectra of hydrogen atom also cannot be explained by the Rutherford experiment. Okay, so these are the some of the limitations that we have for the Rutherford experiment or Rutherford atomic model. Next, to sort out this problem, to solve these limitations, next we have Bohr's atomic model. Okay, so according to the Bohr's atomic model, what will happen? The electrons are revolving a definite orbitals. Okay, a definite track. These electrons, all the electrons, whatever revolving around the nucleus, they are revolving at a definite track, and they have a definite specific angular momentum, that is mvr, that is equals to nh by 2 pi. According to his theory, the uh, according to this Bohr theory, always the electron, the angular momentum of the electron in a orbit which is revolving in a specific track, that is mvr equals to nh by 2 pi, and that is the specific one. Second statement is, Bohr has stated that electrons are not emitting the energy continuously, only when the electron will change its track. Either it will go towards the lower energy level or higher energy level. That time only the electron will emit some energy, or absorb some of the energy. Otherwise, the radiation continuous. According to the Maxwell theory, the electrons should continuously radiated. So that is not actually the case. While the electrons are revolving around the specific track, the angular momentum is specific, constant, and while it will change the track, only that time the what will happen, only that time the energy will change, energy will transfer, or energy will be absorbed. Okay, so okay, so if the electron will go towards the lower energy level, it will emit some of the energy, and that is E. Okay. So electrons revolve around the nucleus in a fixed circular path, that is termed orbit. Okay, the orbits are termed as stationary orbit. Yeah, the orbits, all orbits are the stationary orbit. Okay, the different energy levels, whatever the different energy levels but different stationary orbits the Bohr has suggested, he has denoted as the quantum number, that is called principal quantum number, and that is n. N equals to 1, n equals to 2, n equals to 3. Like this way, the n value will increase. Okay. The different energy levels are denoted by the integers such as n equals to 1, 2, 3 and so on. These are called principal quantum numbers. The change in energy occurs when the electrons jump over from one energy level to another energy level, as I told you. Okay. So, okay, so thus Bohr can solve the problem of the atomic stability, which we which we cannot explain with the Rutherford atomic model, but thus the atom, only the electron will emit the energy or absorb the energy, while it will change the orbits or the energy levels. Okay, so this will exactly this will sort out the problem of atomic stability. And whatever energy and also Rutherford cannot explain the line spectra of hydrogen atom, and according to the Bohr's theory, whatever energy is emitting, that energy, due to that energy, emission of that energy or absorption of that energy, we are getting the line spectra of the hydrogen atom. So these statement, the hydrogen line spectra of hydrogen also can be explained by the Bohr's theory. Now we have to derive, this type of questions are very common, that we have to derive the radius of first orbit of hydrogen atom. So in your exam, this type of question are very commonly you can have. Okay, so derive the first orbit of hydrogen atom, and based on that equation also you can have some of the problems, you have to solve some of the problems. So that also we will see how to solve the problems with the help of this equation, that we will see in the next. Okay, so while the electrons are revolving around the nucleus, what will happen? The electrons having two type of force. Okay, one is centrifugal force and second one is centripetal force. Okay, so the movement of the electron in its orbit would create a centrifugal force. So this centrifugal force we can explain like this. We can write down the expression of this centrifugal force as equals to minus mv square by r. Now, centrifugal force was exactly matched by the opposite centripetal force, and that is why the electrons are stable at its orbit. Okay, continuously revolving around the nucleus, while the centrifugal force and the centripetal force will be similar, will be same. Okay, now this Coulombic force is that is z square by r square. Okay, minus z square by r square. Okay, so mv square by r, that is equals to z square by r square, right? Okay, next that means r equals to mv square r square by z square. So if we multiply the right side of the equation by m by m. So if we multiply this right side equation with the m by m, what will happen? You can see r equals to, we can write down mvr whole square, that is divided by mz square. Okay. So according to the Bohr's model, what will happen? Look, this mvr, that is angular momentum, as I told you, mvr angular momentum of the electron, that is equals to nh by 2 pi. So if we put here this mvr value here in this equation, if we put this nh by 2 pi value in this equation, what will happen? R equals to n square a square by 4 pi square mz square. Okay, so now let me tell you all the all the parameters. Yes, n is the, you know already, the energy levels. H is the Planck constant. Okay, now pi is again a constant. M is the mass of the electron. Z, what is Z? Z is the atomic number, and E is the charge of the electron. Okay, so all these are the parameters. Now for hydrogen atom, what will happen? Z equals to 1, we all know. The smallest radius, that is smallest radius, is obtained from equation 1. So if we put here z equals to 1 in this equation, what we will get? And for hydrogen also n equals to 1. So what we will get? That is A0, the smallest radius, that is indicated by the A0. Okay, so that is A square. As n equals to 1 and z equals to 1, we have put these values. So a square by 4 pi square m e to the power e square. Okay, which is 0.529 angstrom. Because all these parameters are known, the Planck constant, the pi value, the mass of the electron, the charge of the electron, all these values we know. So if we calculate by putting all these values, we can know the radius of the hydrogen atom, that is 0.529 angstrom. Okay. So that means if we put this A0 value, in this equation, number 1, what we will get? We will get R equals to n square A0. A0, what is the value of A0? That is 0.529 angstrom divided by Z. Okay. So for any atom, we can get the radius, atomic radius. Okay. So thus this is the derivation of radius of first orbit of hydrogen atom, and by using this equation also we can get the other elements radius also. Okay, so now you can see, look here, the R is directly proportional to the n square, directly proportional to the quantum number n, the energy levels. Okay, so direct proportional to the square of the quantum number. So quantum number, if quantum number increases, so radius will increase. Quantum number decreases, so radius will decrease. Understand? So this derivation is very, very important. You can have this type of derivation in your exam. So you have to practice well. Understand? Okay, next we will see how we can derive the energy of the electron revolving in first orbit of the hydrogen atom. So now we will see the energy of the electron. Okay. So the total energy of the electron is given by kinetic energy and potential energy. We all know that for energy of an electron, always it is the summation of kinetic energy and the potential energy. So kinetic energy means what? Exactly, that is half mv square, and the potential energy, that is minus z square by r. Okay, so we know that v square equals to minus z square by mr. Okay, from the Bohr orbital, the derivation of the Bohr's orbital, already we have seen that v square equals to minus z square by mr. So if we put this value in this equation, what we will get? That means En equals to what? Half m z square by mr, right? Yes, minus z square by r. Okay, okay. Yes, now what we will get? Minus z square by 2 into 4 pi square mz square by n square a square, and our final equation will be this one. En equals to minus 2 pi square mz square e to the power 4 divided by n square a square. While where you all know that En money, that means energy of the electron, pi equals to constant, m is the mass of the electron, z is the atomic number, E is the charge of the electron, n is the quantum number, and h is the, that is Planck constant. Okay, so for hydrogen atom, what will happen? N equals to 1 and Z equals to 1. So put these values into this equation number 2. What we will get? If Z equals to 1, N equals to 1, we will get minus 2 pi square m e to the power 4 by a square, right? Sorry. Yes. Okay. So this is the final equation that already we have seen. Sorry. Yeah. Okay, so En equals to that is energy of the electron, and R equals to that is n square a square divided by 4 pi square n z square, and En, that is equals to minus 2 pi square mz square by, yes. So En equals to, okay, so this is the energy equals to 2 pi square mz square e to the power 4 divided by n square a square. This is the total whole equation of the Bohr orbit and also the energy of the electron. Okay, now we will calculate the radius of the first orbit of the determination of the first orbit of hydrogen atom. Already we have seen. Okay, now look, so R equals to, yes, what is happening? R equals to, this is the radius, N can be 1, 2, 3, H is the Planck constant, that is 6.626, into 10 to the power minus 27 R per second. M is the mass of the electron, and which is 9 into 9.1 into 10 to the power minus 28 gram. E equals to, you know, ki charge of the electron, that is 4.8 into 10 to the power minus 10 ESU. Z is the atomic number and pi is the 3.14. That all we know. Okay. So what will be the next? So energy of the nth Bohr's orbit, that is equals to, already we know the equation. Actually it should be the radius. Okay. Next. Yes. So the R1, this is not the energy, this is the determination. Look at the question, that is determination of the radius of first orbit hydrogen atom. Okay, so this is not the energy calculation. Yes, so R1 equals to n square a square by 4 pi square mz e square. This is the equation. So if we put all the values, what will happen? We will get the value, that is 0.59 into 10 to the minus 8 centimeter, which is in angstrom. We can write down, that is 0.53 angstrom. Okay, understand? Okay, next we will see what is the next. Yeah, sorry. If the energy of the first Bohr orbit is 13.58 electron volt, what will be the energy of the third Bohr's orbit? Okay, now here we know the we have to calculate the energy of the Bohr's orbit, that is third Bohr orbit. Okay, so while you are solving the problems, you have to check the question very well. First, you have to determine the energy of the first Bohr orbit, the electrons of the first Bohr orbit, or you have to determine the energy of the third Bohr orbit. That you have to check very well. So all these things you know, that is R is the radius, N is the 1 2 3, that is the quantum number, H is the Planck constant, that is 6.623 6 into 10 to the minus 27 R second. M is the mass of the electron, that is 9.1 into 10 to the power minus 28 gram. E is the charge of the electron, that is 4.8 into 10 to the minus 10 ESU. Z is the atomic number, and pi, the value of pi all we know, that is 3.14. And also we know the E1, that is the energy. What is the energy expression for the E1 for hydrogen atom? That is minus 2 pi square m e to the power 4 by a square. So hence E3 equals to minus 2 pi square m e to the power 4 by 3 square n square a square, because this is n equals to, here n equals to 3. Okay, not 1. So that is why we have put here the 3 value. Okay, n square a square, that means 3 square a square, that means E3. E3 means the energy of the orbit 3, or E1, the energy of the first orbit, that is E3 by E1, that is equals to 19. So 19 into E1 value already we have already derived, that is 13.58 electron volt. So if we can multiply with this with 1 by 9, so that will give you minus 1.509 electron volt. So this is the third energy of the third orbit. Okay, so if you have this type of question, thus you can solve, because first of all you should memorize remember what will be the equation for the energy equation. Okay, and after that, for hydrogen first orbit, what is the equation? That is E1. After getting E1, also you can solve the problem of E3. That is the energy of the third orbit. Okay. Okay, next we will see. Okay, so how is the radius of an electronic orbit related to principal quantum number? Okay, principal quantum number. So the answer is given here. The relationship between the radius r and the electronic orbit and the principal quantum number n is given by this. R equals to, all you know now, that is n square a square by 4 pi square mz e square. Okay, so hence r is what, proportional to the n square, hence the radius of the orbit, and which is proportional to the principal quantum number. Okay. Okay, now we will see what are the drawbacks of Bohr's atomic model. So first drawback of the Bohr atomic model is that is, it is valid only for one electron system, that is hydrogen, like hydrogen, He plus, lithium plus. Okay, so this is only valid for the one electron system. Next, orbits were taken as the circular, but according to the Sommerfeld, these are elliptical. Okay, so generally according to the Bohr's experiment, Bohr's statement, all the electrons are revolving around the nucleus in a circular orbit, but that is not the correct one. That is why next in future, after the Bohr's model, we have got the Sommerfeld atomic model also, which explain that electrons are not at all revolving around the nucleus in a circular orbit. Okay, next you can see. Okay, the intensity of spectral line cannot be explained. Look, by the Bohr's orbit, we can explain the line spectra of hydrogen atom, but in presence of magnetic field, in presence of electric field, that the spectral line further splitted. So this further splitting of line spectra cannot explained by the Bohr's atomic model. Okay. Yes, as I told you, that this does not explain the Zeeman effect, the Stark effect. Okay. And one more thing. Okay, so all of you know Heisenberg uncertainty principle. According to the Heisenberg uncertainty principle, what we have, we cannot, for a the moving particle, we cannot determine the position and the angular momentum at the same time, okay, for a particle, but which cannot be explained by the Bohr atomic model. Because from the Bohr atomic model, for electrons we have both idea of the radius and the energy. Okay, so which is not correct according to the Heisenberg uncertainty principle. So these are the some of the drawbacks of Bohr's atomic model, which can be sorted out again with the Sommerfeld atomic model, and which we will discuss in our next class. Okay, so this is a quick review, whatever you know about the whatever you have read today, I have discussed today, how much you have got for understanding that thing. I have given you one question, that is, give one drawback of Rutherford atomic model. Okay, and for this you will get 10-second time. Yeah, so your time is over. Yes, of course. The answer is, according to the Maxwell, if one charged particle will be revolving around the nucleus, what will happen? Constantly that will emit some of the electromagnetic radiation. Understand? So that is why what will happen, if the electron will continuously emitting the electromagnetic radiation at once, at some time it will just collapse into the nucleus, but that is not actual the case. So according to the Rutherford model, we cannot explain the stability, atomic stability, which is one of the drawback of, obviously one of the drawback of Rutherford atomic model. Again, we have another, like, we cannot explain the line spectra of hydrogen atom also. So these are all the drawbacks of the Rutherford model, and these drawbacks can be sorted out further with the Bohr's model. But again, we have some of the drawbacks for the Bohr's atomic model, like further splitting of line spectra of hydrogen we cannot explain. The Zeeman effect, the star effect, we cannot explain by the Bohr's atomic model. Or Bohr's atomic model only valid for the one electron system. Okay, so multi electron system it cannot valid. So these are the some of the drawbacks that we have for the Bohr's atomic model, and which will be further which is further modified by the Summerfield atomic model, and it will we will discuss about the Summerfield atomic model in our next class. Okay. Okay, so these are the recapitulation again. So these are the topics, some of the topics we have covered, that is atoms, electron, neutron, that means the atomic structure, the Rutherford atomic model, the merits and demerits, the Bohr's atomic model, and the some of the numericals also we have seen. Okay, and in Bohr's atomic model we have derived the radius, we have derived the energy of the nth orbital. Okay, so all these derivations are very important. So you have to do the practice the derivation very well, and also you have to remember the expression, because based on that expression you can have the numerical. So finally we have solved some of the numericals also. So thank you, students. Just follow the classes very well, and that time only you can do the assignments and properly, and you can submit the assignment within the time. Okay, thank you, students, and have a good day.